Welcome all Zoomers zooming in today to our faculty Q&A, and also we're live on Facebook. For any of those ones who jumped right on first thing as you saw it, welcome on Facebook. And we're here with our illustrious faculty again for another faculty Q&A. We got a full house. I think we have Robert Grant coming at some point today too. So. And I think Adam and Ines are here for the first hour. So it's great. We're excited to have a full turnout today. This is the Q&A time for our wonderful members who join us in the Academy and join us for these sessions with the faculty every third Wednesday and with Nassim every first Wednesday of the month. And post your questions. And we always appreciate you guys being here so much. We're just super excited to have the Academy being really well attended now. And I don't know, I think it's around 100,000 people, Jamie, is that right? They're in the Academy now, something like that?
We're about 90 now.
90, yeah, that's so awesome, amazing.
Counting up to 100, we'll be there soon.
Yeah, we're getting closer and closer. Well, thank you guys, just keep sharing it out because you know you can. Free for anybody to come in and go through the program and get into some great conversations together. So we really appreciate it. And of course, this is a Q&A, and as you all may know already, well, I want to, sorry, my throat's getting a little choked up. I want to first say, as we should, I don't know, we got to find a way to make it by default. So when you do your chat right now, some people are going in and you're only posting to us panelists because it's not set to panelists and attendees. And so not everybody's seeing your chat. So make sure you go in there and change your setting to panelists and attendees so that everybody can see what you're sharing. We'll remind you again as we go along. But that's always the thing. I don't know why by default it's only to panelists, but there you have it. And then there's the Q&A, and there's the Q&A link down at the bottom of the screen, the little button there where you can post your questions. And currently for me, I see no open questions. I'm not sure if mine is just not updated. We'll see what happens. Maybe we've answered all the questions already and there's no more questions to be answered.
All the questions have been completely answered. The entire universe is understood in its
There
depth.
is nothing else to learn. Didn't they say that something like about 100 years ago? Some famous scientist at the time said, no, we know it all now.
Yep, done.
Ooh,
Oh, good. Simon has a trick question for us, I'm sure.
Right.
But, awesome. So how about we do we got a lot of us here. So how about we do just a quick little round of how we're doing, each of us, and let some questions get in the door here. And then we'll go from there. So Ines, wonderful to have you here always. We only have you for the first hour because you're busy doing some physics.
Yeah.
So
hanging out on the beach.
How you doing? What's happening?
I'm happy at the beach. As you can see, I'm having an amazing time doing physics by the sea. That's the best way to do it. So I'm getting a little bit of a sunburn from my light in the room. At least I have some of my, I can't believe this amazing background. I love it. Yeah, so well, I'm here. So my news would be still working on Module 7. As you know, Module 7 is the continuation of the 6 modules that we have already done from the Unified Science course. So now we're up to Module 7. It's almost finished. I would say it's finished. It's just at this stage of correcting. So we're doing just the final details, final touches, and maybe some minor corrections, and that would be like all. So but that has been that, and well, working also as well in physics, and also exploring, well, all the things that I have to explore during the research also as well, and very excited as well because of all this publicity that's got into this mainstream physics and the A.B. Loeb situation with Omanu, I don't know how to pronounce the name, but of this cosmic object that just went by. So, well, many things that have been going on, and so very happy for it. I'm very happy to be here with all you in this
Thanks,
question.
Ines.
Knowing that we don't have to answer anything because it's already solved. So.
Isn't that great?
We can make up anything we want now.
Yeah.
It's exciting, Ines. I know we're all anticipating Module 7 very, very much. So it's good to hear. Getting down to the last little bits coming soon.
It's the final
That's great.
details. Yeah. Which is
great. Glad you're here. All right. Let's see. Alan, why don't you do something real brief because we want to make sure we get some questions while Adam and Ines are here. And say hello.
Oh, sure, of course. Well, I can sometimes be brief, so I'm glad you reminded me of that. However, did I ever tell you about the time?
Yes, you did. Yes.
Yeah. Hi, everybody. Lovely to be back. I'll be brief. We got a resonance course starting very, very soon. It's going to be announced within the month. 3 courses, actually, that are a culmination of 17 years work of A, on Shakespeare codes, B, on how they flow across into mathematics and sacred geometry, and C, how they then ultimately end up in the alchemical blend of the third part of it. And so I'm really excited bringing it to you. I hope you have some questions for us, because on my end, every question has not been answered. I'm still asking a lot.
Alan, the beauty of what you're doing is you bring a lot of new questions in to be considered. It's really exciting that your elective program is coming up very soon. For those who don't know, Alan has been decoding the Bard, Shakespeare's works as it relates to cosmic geometry and the pyramids and Da Vinci and Veer and so many layers that are just extremely compelling and rigorously analyzed by Alan and presented in such clear ways that it's going to be really cool. It's going to be a whole other dimension, and definitely there'll be some new questions. No doubt.
I will only just say that it's not what you think. When you think of Shakespeare, people tend to think, oh, well, that's kind of dull and old tweedy jackets and forsooth. It's not that at all. It's who that writer or writers really were and what their true mission was behind the dramas, which all ends up being totally connected to all of our work. It's a side that the world is utterly unaware of as yet about who this being or beings were. And that's the question. That is the question.
Yes,
You see?
indeed. All right. How about Adam?
Definitely check out Alan's work, guys. Honestly, I've had the beautiful opportunity to know Alan for a couple of years now and follow his work and, receive some of his presentations hot off the press of his frontal lobe, so to speak. And it's literally like one of the most compelling mysteries of all of history getting unfolded in the work that he's doing. And it's just some of the most incredible work I've ever experienced. And just super excited to see the journey of his work unfold in that space. And I'll actually be giving Alan a little bit of a shout out this weekend. I'm speaking at the Conscious Life Expo. I have the opening keynote talk this Friday night at 8 p.m. Pacific time on ancient mysteries. And my particular talk is on the ancient mysteries of our human origins. So where we came from and who we are and how do we get all these epic megalithic sites all over the planet and what's the connection between them? And I'll be putting in a few mentions on Alan's work around the Great Pyramid and the Bent Pyramid and their geometries, the super advanced kind of knowledge encrypted in those, as well as surfacing some of the work that William did with Nassim in studies of the Caracas skull from Peru, showing some of the DNA output of that and how it basically definitively proves that we've got skulls and mummies all over on the earth that are clearly not human. So it's going to be a pretty exciting talk. Please come and join me for that. I'll actually just post a link you can use to register. And of course, you know, it's got my name on it. So please use that link because it helps them know that like there's people that care about my work and it'll get me talks in the future. And then Saturday morning, I'll be doing another talk on the unified harmonic matrix, but it will be a briefer talk than my kind of hour and a half deep dive that I do on YouTube, which definitely encourage you guys to check out. This one will be more high level and covering some of the major updates that I've had over the last couple of years since that talk at Contact in the Desert. So love to have you guys come and join me for that. That's mainly what I'm up to and preparing for, and then I'll be doing some cat skiing up in Aspen on Sunday. So full on weekend for me ahead, and really excited to be here as always and answer some of you guys' questions. Serve up the tough stuff. Come on, bring it on.
All right, rockstar lifestyle happening. Go,
Yeah,
Adam.
gotta make it happen.
That's awesome. I didn't know you were doing that this weekend. That's fantastic. Definitely.
Thank you.
Check that out. Yeah, I see the link there. So check that out, everybody. Jamie, what's happening for you, brother?
I just want to reiterate how epic Alan's work is, having been on the inside of seeing some of the stuff that's coming down the pike. These 3 courses, it's like Alan's life's work. The last 17 years, he's been digging super hard into this. And I have to say, like, if you miss those days where you first discovered Nassim and he would like start talking and you'd be like, oh my God, that makes so much sense, and have like your mind blown. I get that feeling every time Alan shows me something new. David and I yesterday were like, what? Are you kidding me? It can't be a coincidence. It's kind of beyond belief. So that's what I have to say about it. And we put the links into the chat here on Facebook and on Zoom for you to pre-register for when this comes out. It should be soon. I'm looking forward to it. And as well, Inez has been crushing figuring out how to encapsulate all the information and all the papers that Nassim put out since 2015, since we originally put out the Unified Science course. So that's module 7 coming, and that's going to be another huge download, and that's going to be free. And the course is already free. So it's a reminder to everybody right now that can hear my voice, you can take a free course right now that is Nassim's entire life's work encapsulated, because we just are on a mission to unify science, and that's the best way to do that as the foundation. So tell your peeps, you know, like, such an epic download. It's many hours worth of going down rabbit holes fractally. So, and then we also have Marshall eventually, right, coming out with a course as well. Check out Cosmometry. Highly recommend Marshall's book as well. So that's my update.
Thanks, Jamie. Thank you. Appreciate it. Yeah, one of these days I actually have a couple of people translating my book into Spanish and Portuguese right now. So it's going to be a massive job for me to put those translations into the layout. That's going to be my course, I think. So I've got a lot of other cool things going on. Kind of difficult to weave into a quick summary. I would just say, though, if anybody has not yet been able to watch Thrive 2, that's a film that I helped co-produce and as well as co-directed the visual effects, which depict the unified field in some particular ways, the geometries and dynamics. And that's really kind of the front and center of the film is the unified field. So check out Thrive 2 at thriveon.com. If you haven't seen that, you'll see Nassim in there talking about the theory and some really cool animations, like one of the resonator technology. It's just beautiful. Came out really great. So yeah, all right. Well, let's see. I think there's some good questions here. Really interesting stuff to consider. And we have Adam and Ines here for a shorter period of time. I presume, Alan, you're here a little longer. So do you guys see something you want to jump in on? We can, we don't have to go from the top down. We can kind of bounce around as we wish today.
We can't hear you, Inez. I hear you. I see you trying to jump on though.
Yes.
Yeah.
I see you.
Thanks. I was completely muted. Okay, here we go. It's the question about the electron, which is something, it's very interesting. Richard Haringberg makes this question. Is it going to work that you put the person in the panel and so we hear him make the question, or we just have the, oh, okay.
Yeah, I'll bring them on. I'll bring
Okay.
them on. Yeah. But you can go ahead and start.
Yeah, okay. Well, this is a very tough question because, you know, the electron, one of the mysteries of the electron, it's determine its size. One of the things that happens in the mainstream, let's say, physics, is that we have to decide, like, there is no actual definition of the radius of the electron. What it is known as the classical radius of the electron, it's said in every page, and if you enter into wiki and all that, it will say that it's just like a nominal radius. It's not a real radius, because the radius, when it's measured, let's say, and from the theory of standard particles and all that, it's just it's a point particle. It is considered a point particle with no volume, no size, no. So that's really weird to address, not from the point of view. Now that's from the point of view of the standard model, and from the point of view of QED, quantum electrodynamics. So that's what you obtain. But in the perspective of the holographic theory, that changes a lot. The article that was written by Amira and Nassim, the electron puzzle, it was that paper that was published in 2019, I think that was the year. In that article, you will see, in that paper, you will see that the solution for it was considering, you had to consider, like, in the context of the proton, the electron was just like part of the system. And so you have, in the atom, you have, like, you know, as we're all familiarized, there's the nuclei, there's the nuclei has a proton. Like, let's take the most simple atom, which is the hydrogen atom. So in the hydrogen atom, you would have a proton in the nuclei, and you would have like a surrounding electron. The description of this electron has changed, like from a point particle, you know, messing around. We know from quantum physics and from quantum theory that that's not the correct depiction, or that was not the correct depiction for the electron. It was most like a charge, a distribution around the nuclei, around the proton, this charge distribution. So when you consider, so what I'm trying to get into this is that we have like two kinds of, let's say, the electron, which is bounded to the atom, and what we know as the free electron. Okay, so the depiction that we have for the electron in the model that is described by the paper from Amira and Nassim, in this view, the electron is part of the system. It's not a separate entity. It is the expansion of the vortex up to a certain level. So if you recall, the nuclei is a vortex which will have the PSUs collectively spinning. That would be like the proton, and the spin would speed of rotation would decrease at some point up to reaching the speed of the electron. And in this solution, which will be presented in extreme detail in module 7, that's where you will see like all the derivations and what's the hypothesis behind, and how we calculate the electron mass and the radius, let's say, of this of the system. Then it will answer the question how many PSUs you could consider for the electron, because in this view, what we're taking as the electron is the Bohr atom. We're taking the whole system as a single entity, and we're taking the radius of the system as the Bohr radius. So you have to take into account the numbers of spheres that would fill in this volume of the Bohr radius, which, as we know, is an approximation for for an atom, not for the electron. So in now the next step would be to precisely describe the electron outside of the bounded system. This means the free electron. And in order to do that, we would have to calculate the ionization energies. We would have to do a model for ionization. This means when the electron, it's no longer like part of the system, and it has been in the classical view, let's say in the standard view, it is excited and it is taken outside of the atom, and so it starts being like a free particle. And in this view, we have a lot of work to do. We are just starting to do these calculations, so we don't have that model finished yet. So this is like the way we solve the electron is still a solution in the bounded system, which is the proton, which is the atom, sorry, the hydrogen atom. So you will see in detail these calculations in model 7, but for the time being, that's what we can say.
Thank you. Great answer. And I'm looking forward to some more. I have searched the internet and found a whole range of answers from 10 to the minus 10 meters to 10 to the minus 30 meters.
Yeah.
And they're all interesting answers. What I concluded is that it seems like the electron changes its size depending on its energy, and that it gets larger with more energy.
Mm.
So similar to the orbits around the nucleus,
Yeah.
the different energy levels.
Yeah, it is very similar to what we have in the article that's been published already, in the paper. You will see that you can describe all atoms in the periodic table as having all the electrons in the first shell, which is the n=1 shell. It's considered like and the holographic solution gives that response. It gives the fact that you could consider that these are all like modes of vibration of the hydrogen atom when you have excitations, when you have like multiple excitations. So in reality, and in this same solution, you would also see that what you have just said, that there's like this velocity relationship, and which is, we call it in relativity, it's the mass dilation. It's because if you increase your speed, you would be dilating your mass. That's one theory of coming from relativity. And it's really how we solve the problem for the electron in the bounded case, which is considering that if you have this vortex in the nuclei, and then you consider this velocity relationship while you go out of the vortex, just as a rubber ducky just going out of the drain, you will see that its speed would slow. And at the point where it gets the relationship of velocity of alpha c being alpha defined structure constant, at that point you would have the speed of the electron, and that is the solution. And when you see that solution, it corresponds with the mass dilation that corresponds to the value of the electron mass. You see, so you have the electron mass exactly at that point, and that's when the system, let's say the model, goes into coherence. So that's why we say that the electron is just a cloud of potential energy, a real cloud of potential energy, not a probabilistic distribution of charge. It is a real distribution of spin, let's say, around the nuclei, around the proton.
Yeah, if I could, Inez, maybe just to translate, you described that so well and so sophisticated, and for just kind of the breadth of our audience, I'll just say, you know, if we look at the electron as not an object, but as a co-moving field of the PSU, the field itself that's in torsion around the spin of the nucleus of an atom, then that entire field is moving. And the more of the field that is co-moving, in other words, the amplitude of that co-moving field, i.e. the bigger the electron, so to speak, and the shell layers are like the harmonics of that field of spin. So there are spots where there's a speed relationship to the core that also is a distance relationship that's at a harmonic distance point from the nucleus. And thus then we get these sort of like harmonic resonant wave ripples around this spinning nucleus. And those harmonic wave ripples are what we call the kind of different electron sets.
Yeah, exactly. And the orbitals also. That's what you would also interpret as the orbitals. But in this in this view, as Adam just said, it's a continuous view. You don't have the separation between this object, and it's just the field, the Planck field, which is having these dynamics. So the dynamics is what we call orbitals and electrons and all that. Exactly. Thanks.
Thank you.
Awesome. Very clear. Thanks for joining us, Richard. We see you have another question here regarding the art crystal, and I think we may have William Brown coming on a little bit later, and he'd be probably the optimal person to address that question. So we'll circle back if he comes on. Thanks for joining us today. Appreciate it. Hello, Robert Edward Grant is in the house. Good to see you, man.
Hey, Marshall.
Welcome.
How you doing, buddy? I like your picture background.
Yeah, Lakshmi. Isn't that nice?
Mm-hmm. Beautiful.
Lots of abundance. Yes. Well, we're doing a little question rounds while we have Adam and Ines in the first hour. Sure. But do you want to just say a quick hello to everybody and just do a little check-in as to what's happening for you, and then we'll jump back into it.
Well, hello, everyone. Good to see you all, and nice to see all your faces too. I'm looking forward to the day that we can actually be in the same room soon. I'm hoping, or maybe on a trip somewhere, because I'm kind of jonesing for a trip. I'm already like planning. I'm like, okay, I got to figure out a way to get back to Egypt. So I was going to post a question pretty soon on my social media and say, who wants to go to Egypt in the fall? And I think I'm going to get quite a few people that want to go. So, I'm feeling like it's time to get back. So don't you feel that way? It's like it's been a year.
Totally.
It's been a year since the trip. Jamie, Adam, Alan all came to Egypt last year with us, and we came back, and literally it was only a couple days after that the borders closed. So it was literally, we closed down Egypt. That's what we did. We closed it down. We closed down the pyramid.
We saw the very last bats. We were there in a cave getting shat on by bats, and then we get back and they say, don't go near bats. And we go, what?
Right.
Okay. We were just in the caves getting totally blasted by them.
That is absolutely true. But so what I've been working on, Jamie knows because I was just on the phone with them like literally right before this call, and I had an interview for someone we're hiring on our team here, and I've been working on some mathematics that is very, very interesting, and it relates to space-time and right triangles and factorization.
And for some reason, you cut out, Robert.
Oh, you lost me for a second?
Yeah.
Yeah, was that?
Yeah,
that was
probably only the
real quick.
really important part, though. So
yeah, the only really important part. Alan knows I was up pretty much all night last night. As usual, my little son was not sleeping so well, so I had insomnia as well. And while I was up, I was figuring out some new relationships mathematically that relate to some new mathematical constants that I believe play a really fundamental role, like the golden number. One of the things that makes the golden number so special is that when you take its reciprocal value, it has the same mantissa, or the same decimal extension. So 1/5, the golden number, is it's a 1.618033987, If you take 1 over that, it still comes out to 0.61803398887. So that's kind of a unique thing because, you know, it's like a black hole, right? It's got on both sides of, you know, this X and 1 over X mirror, you've got the same number string. And that doesn't happen that often. It also happens with the square root of 10. So the square root of 10 is 3.16227766. And 1 over the square root of 10 is 0.316227766. So it's an identical number, right? And so in a paper that that both Talal and I published on something called fractal rooting of numbers, we've now found 4 different ways of square rooting numbers and fractal rooting numbers across fractal zones. So, you know, 3.16227766 multiplied by 0.316227766 equals 1. So the universe looks at the number series and says, oh, it's the same number series. The decimal point is the point of perspective from the observer. So it has to be able to operate across all fractals, right? In all directions. Well, I found another number which is very unique that has the same property that I didn't really understand had these exact same properties. And that number is something that I call Phio. It's funny because I named it Phio. And just like phi, if you square Phio, which is 3.660254, if you divide that by 10 and add 1 to the front of it, so it becomes 1.3660254, you end up with an identical mantissa, which that's new. It's news to me. I've never had a number that squares that has an identical mantissa except for phi. So phi does that. So phi squared is 1.618033987, and squaring it takes you to 2.618033987. But when we do the same thing, I'll just show you what I mean here. Actually, if you let me share, I can show you guys what I'm talking about. Oops.
Looks like we're seeing your screen now.
Yep, and I don't know why I'm not. Hang on a tick. I should be able to get into.
We were seeing a
calculator.
A
What are you
page.
seeing? Can you see?
Okay.
Can you see the calculator now?
Not the calculator, no.
Okay, hang on a second.
Yeah, it came up at the end
At
there.
the last minute we saw it, yeah.
Oh, did it?
Right. Yeah, I have a bunch of stuff on my computer that I've been working on. So, all right. So let's take phi, right? And we can derive phi as the square root of 5, right? So that's 2.236067977 plus 1, and then divide that by 2. So that gives us perfect phi, golden number, right? So, and if we square that, look what happens. Same number, except it goes from 1 to 2 in front, right? So that's something very unique to phi. Very, very unique to phi. And I didn't think that something like that existed somewhere else until last night, which I had found that. Now let's take a different way of looking at phi. So what are some numbers close to the square root of 5 that you would expect that maybe would follow a similar convention as the golden number 5 does? So what are the numbers closest to that would be square root numbers? So you could take the square root of 6, which would be 2.449, or you could take the square root of 3. Those would be the two closest, right? So let's see what happens when we take the square root of 3, add 1, and divide it by 2 in the same equation that we just did with the square root of 5. You guys with me? So let's take the square root of 3 plus 1 and divide that by 2. Gives me this number. Now, what happens when I square this number? Whoops, sorry. There you go. Look at that. The same mantissa. The only difference is it goes 1.866025403784439 versus 1.3. So the only difference here is 0.5.
And
Inez, go ahead, Inez.
the 5 number, that's the 5. I don't know why I thought of that. It's, you know, to construct phi, you had to use the square root of 5. And the difference between 1.3 and 1.8 is 5. I don't know why you thought about it. It's just.
Yeah, no, that's right. You see, now that's exactly right. So now let's see what else happens with this, because this is kind of really interesting.
Yeah.
So
yeah.
let's take this number and square it again. Now let's multiply this to find the fractal root pair, right? So the way I could do this 2 ways. I could either take this 1.3660254 and I can multiply it by the square root of 10, right? Square root of 10.
Hmm.
432.
Mm.
So isn't that interesting?
Yes.
432.
It is.
Where have we heard that before? Why does that work? Well, because 4.3197516 squared gives me 18.660. To find the fractal root of that, I just divide it by 10 and then take its square root. And now I'm back to this number that, remember, was simply derived just like the square root of 5 for phi plus 1 divided by 2. Very fundamental. It's a golden number. Now what we found is something else that's very, very interesting, because we've just taken the square root of 3 plus 1 divided by 2. And now we've got this number. And when I square it, it has the same characteristics that phi has. The only difference is, instead of increasing from 1.618 to 2.618, adding 1, I'm adding 0.5.
Yeah.
Isn't that interesting? Now look at some of the other characteristics of this. Let's say I take that number.
And Robert, we're going to want to, Robert, sorry to interrupt, but we're going to want to get to some questions while Adam
Sure,
is here.
sure,
and
absolutely.
So I want to just not get too long with this, but
Sure thing.
you come
So
now.
So the point that I'm trying to make on this is that there's something very unique about this square root of 3 relationship, because when we look at this, look what happens with this number as well. So the 1 over x of that same 1.3660254, right, gives me 0.73205080756. Just remember that number. Now look what happens when I get rid of the 1 in front. I'm going to subtract 1 and do the 1 over x, and it's the exact same number, 732050807568877. The only difference here is there's 2 in front. So just like phi adds 1. So this is something very fundamental, and I believe that this is a higher dimensional phi, and that there is a higher dimensional phi. Yes, there's a higher dimensional golden mean, and it relates back to 432, because that same number gives me another number of 1.6339. If I square that number, it comes out to 2.6698, which is 0.61803 times 4.32. So 432 is like an anchor between these. And as you guys have seen, that all the separations of the flower of life give multiples of 1 over 432 relationships. So there's something that's emerging out of this that's very, very, very interesting. But I'll just leave it at that.
Wow. Not bad for a sleepless night, Robert. That's really cool. I can see, I can intuitively see that harmonic relationship, like you said, this higher dimensional aspect, which would make sense, because why would it stop there? You know,
So this is
we
phi,
know that
instead of adding 1 to create the same mantissa, the same decimal extension, you're adding 0.5 or 2 on both sides of the 1 over x.
Yeah.
Right,
That's
because
great.
1 over 5 is 0.2 and 1 over 2 is 0.5. So that's
Doubling
the
or
relationship.
halving.
It's fifth dimensional phi.
So it's in an octave relationship. That's really cool.
And it's a base 12.
Great. That's awesome. All right. Well, thank you for that download today. We'll get some more with you. Are you able to join us for a little while, Robert?
Yeah, I can stay with you guys.
Great. Awesome. Okay, great. Great. Well, Adam, why don't you pull up a question here that has caught your eye?
Sure. Yeah. Yeah, it's funny how things come back around full circle, Robert, as you were talking. I was just remembering seeing some of those numbers with that phi kind of relationship. It was almost like a year and a half ago or something. And we were like scratching on some of them, seeing those mantisas come up in different operations. And then it kind of faded away. And it's interesting because it seems like, you know, sometimes stuff like that, it's important, but we don't know the relevance yet. And then it comes back a year and a half later. And now there's enough other pieces of the puzzle that you can start to kind of fit it into the rest of the whole, you know, matrix of the work that you're doing. So yeah, just want to observe that phenomenon and how cool it is. So on in terms of the questions, you know, I kind of glanced through here. One of the ones that I think is clearly in my wheelhouse as a faculty member here is to respond to Oriana, who asks, can you concisely speak to the confusion regarding the Copenhagen interpretation? So first of all, I'll just say that, yeah, there's a huge amount of confusion around the Copenhagen interpretation, and that's not new. That's always been the case. All the way back to the days when the Copenhagen interpretation, as kind of a formal set of rules of quantum mechanics, were being created, because the two guys that were part of developing that sequence of rules and theories were Heisenberg and Bohr, and they disagreed on their own interpretations of things. You know, where Bohr looked at sort of the model of, you know, is it a particle? Is it a wave? When we look at these experiments, what's actually happening? Bohr thought that, you know, it must involve the nature of the experiment and the nature of the tools that we use that is going to determine how we perceive the outcome of the experiment. Heisenberg took another route and said, well, no, I think it's basically a probability that is being a wave probability that's being reduced by the observer. Later on, other physicists decided to say that's collapsing the wave function, right? But that wasn't even originally in their terms about talking about this. And so the kind of set of rules created by the Copenhagen interpretation actually goes kind of far beyond what we even discuss in the unified physics courses, because it involves interpretations of, you know, are quantum physics occurring with individual objects or just sets of objects? Is it about the measuring device or is it about the observer? And, you know, is there a threshold between when we see these kind of quantum superpositioned wave particle effects and where those don't happen anymore? Like, is there actually like a specific threshold? And even the Copenhagen interpretation doesn't define what that threshold is, right? So there's been confusion even in the fundamentals of understanding of what that quantum mechanical set of rules would establish. And they started to get a little bit clearer after guys like Einstein and Schrodinger pushed back really hard against those ideas. Einstein was quoted at one point saying, so are you telling me that if I don't look at the moon, it doesn't exist, right? And he and Schrodinger passed back and forth a series of letters to each other. And, you know, and basically each of them had their own ways of kind of making fun of this interpretation. Like, okay, it's kind of ridiculous. Does this mean that like everything is optional until it's observed? You know, it goes back to the old, if a tree falls in the forest, does anybody hear it kind of stuff? And Schrodinger proposed this interesting thought experiment where he said, okay, so if you're telling me that this is the case, we put a cat in a box and we have a little, you know, superpositioned radioactive particle. If it decays, the cat's dead. If it doesn't decay, the cat's alive. So is the cat alive or dead in the box, right? And what the Copenhagen interpretation would say in general, mostly based on Heisenberg's writings, is that the cat is both alive and dead, superpositioned at the same time until you open the box. And then at that moment, it collapses and suddenly it is one or the other, right? Which both Schrodinger, by the way, and Einstein thought was kind of ridiculous, right? And then there was another guy who came into this story, and his name was Winger. And Winger said, okay, well, what if you stick a guy in the box with the cat, right? And he's observing. Well, if there's a guy in the box with the cat, then he's going to perceive the cat is alive, right? He's going to be in the living box with the cat. But what point does that superpositioning effect occur? Well, this comes into play around that boundary of observation. So if Winger is close enough to observing the cat's relationship to the radioactive particle, then he will be in the same experience as the cat. And if he's outside of that window, then he's not, and he'll have the same observation as the person opening the box. So there's a bunch of weirdness in all of this, right? Like it gets really, really weird. And as you get further into kind of modern physics, since that time, 90% of quantum mechanics physicists agree generally that the Copenhagen interpretation must be true, because there's just not really many other explanations. There's not really another way to interpret it. It simplifies a few things. It makes it easier to accept the results of odd experiments. But for some of us that are unified physicists, myself included, I'm highly interested in actually what's really going on underneath the surface of all of this stuff. And the one big piece that's missing in all of these interpretations and rules of the Copenhagen interpretation and its following, positive and negative interpretations, is the underlying field. None of it accounts for the fact that there is an underlying substrate in the field in which these radioactive decay is going to occur, for example, in which light is traveling. Jamie?
If only those physicists were sailors.
Yeah, exactly. Sailing on the ocean, right?
Right. They're making waves themselves.
Exactly. And when you look at things with this underlying field, this underlying substrate, everything starts to look very differently. It's just like what Inez was describing around the electron. Like if the electron is a point particle, with no size, that means that it's infinitely small. So what is it that we're even talking about, right? But when you talk about the electron as a field of charge that can also have a point, a sort of center point of its defined position when we choose to measure it in that space, what you're looking at is the sort of center point of a vortex, the center point of a spin. And it looks like there's a thing there, but what it actually is it's the middle of the place where everything's moving, right? And so when we're sending light waves through a field with a particle slit experiment, is it a particle or is it a wave? Well, since light is what makes up the underlying field of space-time, and we're shooting a charged sort of wave of that light that's moving through that structure in space-time, yes, it has the ability to be measured for its position based on the tool that's measuring it. In that way, I would agree with Bohr, right? But it is also creating a ripple effect, and that ripple effect is creating a waveform that is there whether we measure it or not. And in that way, I agree with Heisenberg, because that waveform is underlying the field, that if we keep shooting tons and tons of little charge points through it, then eventually we're going to start to see the articulation of that full interference pattern that is the wave that's already there in the underlying field, right? Does that make sense? So it's like the interference pattern, the wave pattern is already present, and we're just choosing to look at it where and how we're choosing to look at it, right? And in this way, it's really beautiful as we start to kind of zoom out and we say, well, what's that edge between where those quantum mechanical effects are happening at the micro scale and what we're experiencing at the macro scale? Well, the reality is there isn't an edge, because no matter how big you get, what you perceive is still going to be based on how you perceive it. Your perception of what is determining what is within your reality. And both sides of that reality are true. In other words, you know, when we apply this to things like the Einstein-Podolsky-Rosen paradox, or EPR, which is entanglement, we start to see some really interesting things. Because you can say, actually, well, is it possible for two spaces to be entangled and information to be shared instantaneously without a feedback loop? In other words, without me saying, you know, all right, like this particle is entangled to that particle, and now the only way I can know if I change the spin of this one that it's changed the spin of that one instantaneously is if someone over there sends me a message slower than the speed of light and confirms my observation, right? This is the way they get around it, to say, oh, it all fits within Einstein's theory. Nothing's traveling faster than light. But in reality, that is not the case at all. In fact, I could have an experience with somebody else that happens in simultaneity, and I may not know about that experience for months or weeks later. And it still happened in simultaneous fashion. And we see this all the time with people sharing dreams, with mothers having instantaneous recognition that their child who's halfway across the world has just had an injury or had something go on with them. There's no message back confirming that, right? And yet this simultaneity is happening. And the more people pay attention to the timing of that, you know, and you can get it when you think of someone and all of a sudden they call you on the phone. That's simultaneity right there. You had the thought, they called you on the phone. There is an entanglement of information that's going on, that's being exchanged in that moment. So these things are not isolated to the microcosmic quantum world. They are embedded in every aspect at every scale of our reality and our experience.
I like to
just
tell
want
people.
to add that.
Oh, I just wanted to add that I like to tell people in relation to this that to just imagine the mechanics of it, that you have an experiment in a swimming pool and you're like, okay, we're running the experiment. And then you jump in the pool and you're like, look, because I was observing the experiment changed. It's like, yeah, you're in the pool with the experiment. What do you,
Right.
That's why I said you need to be a sailor, because there's mechanics for this. They've replicated this with silica, like on a macro scale, the same pattern thing with the slits and all that stuff with big stuff that you can see in a bath on a table, right? So there's mechanics for this. There's no weirdness really. Like there's the weirdness is there's no mechanics for it, and there are mechanics for it. So it's actually not that weird. It just seems weird.
Yeah, I would like to add, because this, just what a coincidence, talking about synchronicities. Just a while ago, I was looking at a video in an interview, and we were discussing the fact that why do we get to have this philosophical, like, let's say, dilemma about reality not being real, because this all, the consequences that had the fact that we had this duality, particle wave duality, which was somehow contradictory with the fact that we had discarded the existence of the ether. So this is quite weird, because on one hand you had, and this was happening almost at the same time, because we discarded, oh, I have my hands moving so fast that I lose my arm into the sea.
It was both there and not.
Oh my God.
It's big and not big.
Let me know if a shark is coming. Okay, so the thing is that at the same time, and this is really interesting, we were so in the physics community, there was all these issues going on at the same time. There was this issue about concerning the ether, because the discussion was there has to be a medium where everything is happening, you know, and the stars and planets were all like be suspended on this kind of medium where, like, and that light travels through and all of that. And when this ether was discarded. That was at ending of 1800, almost starting in 1900. This ether was discarded because of the experiment made by Michelson Morley experiment. So basically, in that experiment, there was supposed to be if the ether existed. Uh, of course, if the ether existed, we would have expected some results, which we didn't have. So the conclusion was ether is not existent. We don't have any ether. So the perfect vacuum is possible. We have the perfect the vacuum. If you put something inside a vacuum, it's completely isolated. And the thing is that if we replicated those experiments with the technology that we have now, we wouldn't have the same conclusion. We would see there is this dragon, which is which comes from the fact that there is this ether, which in relativity theory, it is explained as a space-time continuum that bends. And on quantum theory, it is explained as the quantum vacuum fluctuations. And these two visions are not unified. They're not unified because they're explaining the experience from different perspectives. But the interesting thing is that even if you take a little bit of distance, even from that time, you could have seen that there was a contradiction going on, in which in one side you were saying no, ether is not existent, but on the other side, almost at the same time, you were having theories that were bringing you versions of the ether 2.0, 3.0, like relativity and quantum physics. So, and this all connects as well with the fact that you could suppose then that systems were completely isolated, that you could really create isolation, and not even that they were fundamentally isolated because nothing was connecting. There was no ether, so there was no connection. The space-time is supposed to be like, let's say, non-interacting with anything. So it's something that bends, but since mass is not supposed to be emerging from it, then you could suppose as well that there's this isolation. And as well, from quantum theory, the quantum vacuum fluctuations are supposed to happen just at the very, very far quantum scale, and so not having any impact on the macroscopic world we have. So all these pieces are completely confusing and create huge confusions in the scientific community, which could be easily solved if you consider this unifying field, which is basically acknowledging that the unified field, the substrate, which is underneath, is connecting everything, and everything is emerging from it, from its dynamics and from its geometry and from its structure. So it is really weird how on the same period of time you were having all these things. I guess it's because we didn't have internet, maybe. So the communication between scientists was very complicated at the time, and they had well, we had the phone, I think, yeah, but 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 you don't have the portable phone, so you cannot have them all the time when you want to reach them, like, hey, I have this idea, or a WhatsApp message, I'm having this idea. So
it took such a long time to dial because they were rotary as well.
All the time you have to spend to dial, yeah.
Yeah.
So
like in England, we have this. If there's an emergency, you have to dial 999, which would be the longest possible number. It's an emergency. 9. Oh. Sorry, Inez, carry on. I just couldn't resist.
Basically, the wave-particle duality was contradicting itself. Even if they got into the conclusion that you have this duality, it was contradictory. It was in itself a contradiction with what was happening at the same time through quantum mechanics and relativity. Because if there was this ether, which they saw it was, because you had, as I said, in relativity space-time and on the quantum scale, the vacuum fluctuations, you could have assumed there was this field. And this brings me to de Broglie and his pilot wave theory. He had thought of that, and he has said, but because the ether was discarded, his model was completely thrown apart. Instead of thinking, wait, de Broglie had already this solved in terms of mechanics, in terms of fluid mechanics. It was just a medium which was having an interference and was serving as a pilot wave for the particles, and this was all called pilot wave theory, de Broglie theory, and because these experiments that Jamie just mentioned about this silicon, which were performed by a French person, a French researcher, which name I don't remember now. Well, but this is very recent. This is just 10 years ago. And he was reproducing, I mean, he just took a pool, let's say a little substrate of silicon, and it made it vibrate, okay? And then you take a little bit of like something very pointy, and you just take a little drop of it. So from this liquid, you create a drop, but the liquid is still vibrating. And so the drop, because of the viscosity of silicon, it didn't immediately, dissolve in the water. It just kept on the liquid. It just kept its form. So you would have this phenomena of the silicon and the little droplet, and you would see reproduced by this person. I can't believe I don't remember his name. Reproducing all the effects that you would see in this quantum world. The quantum weirdness was reproduced by a particle, a droplet, which was just piloted by the substrate, which was the field, this bath that is the silicon bath. So he reproduced all this quantumness, weirdness in classical terms, and now there's this huge discussion, because then I think it was the nephew of Heisenberg who said, no, this is not possible. And so there was all this mess around, but these French people his French researcher who just did this pilot wave theory with silicon, I can't remember his name, I'm sorry. Yes.
It's okay. It's okay.
I know, I'm looking for it. I'm trying to help you. I can't remember the
I know Adam's looking.
Name. But you see this, it's an open question, and it's the probability, and so this wave particle duality, so it was easier for them to assume then that if we have this duality, then the only way that you could describe this mathematically, if you're using the Schrodinger equation, which is a wave equation, it's to take, then the wave equation is describing probabilities distributions and not real charge. It's just a distribution of Yves Coudet. Yay!
Dr. Yves Coudet.
Yves
Coudet.
Coudet. Yeah, that's the guy. Thank you. Yeah.
So we leave it at that.
Yeah. So I'll just finishing to say that because of this wave particle duality, then you had to get into this probability interpretation of the Schrodinger equation, and this is where it gets really even more weird, because then you say that reality at the quantum scale is a probability. It's not real, it's just probability. And then something happens, there's a transition phase in which then in the macroscopic world you have determinism, and this transition from one state to the other is not explained in anywhere. They say it's quantum decoherence, they say a lot of things, but it's not explained. And it is just because it is misconception, it is a misinterpretation happening because of this wave particle duality and the Copenhagen interpretation.
So Inez, why don't we just
great follow-up.
Let's all just decide that COVID's done.
Yeah. Well,
the cat's alive. The cat's alive. And Jamie got it right there.
Well, that's precisely why we cannot do that, because one of the interpretations in spirituality of the quantum theory is this is a huge mess, because then you have oh no, so then because of the conclusions of quantum mechanics, we can say that I can create my reality with my intention and just with my thought, and that is not entirely correct. That is not how it goes. So you cannot do that.
That's based
More to it
on
than that.
one observer's perception, though,
Yeah, of course.
Mhm.
right? So that is
More
exactly
than
how
one
it
outlet.
goes. That's how I've lived my whole life. I mean,
Yeah.
literally, that is true. You know, it's like,
For
and
yourself. Yeah.
yeah, but that's the whole thing. Is like, you know, is it a circle or is it a rectangle? Right? We can all argue over this, but actually it's a cylinder. It's the higher dimension. That's the truth.
Yeah.
You know,
Yeah,
is it
that's interesting.
destiny, predetermined, right? Destiny, or is it free will, or is what we call destiny just the free will of a higher self somewhere?
Mhm.
Mm.
Yeah, and I look at it as like there's literally a tensegrity, as Buckminster Fuller would call it, between the shared perceptions of any group within any environment. And that including within the entire open system of the universe. So we're actually behaving within the shared agreed upon reality state that's collectively generated and held together in the tension of everyone everywhere, which is also why in certain situations as individuals we can experience massive shifts in reality that we create and change for ourselves when there isn't a bunch of other observers watching, right? But when there are others watching, and I did this actually in several experiments where we were like having people basically, we put these little balanced objects inside a glass cover. We did this in Detroit at this expo that was there one year. And you basically move the object inside the little glass container with your mind. And it's like feather light. So it's very easy to get the thing to turn. It's just a little balanced paper thing. And so, but when there was people watching and they didn't believe it would happen, nobody could do it, right? But as soon as we got everybody watching, like we got one person to do it, as soon as someone did it, then everybody started believing it was possible. And suddenly everybody's doing it and everybody's moving it. And this is exactly how spoon bending tricks work as well. And others, it's about creating that collective tensegrity of belief that we can shift it together. And I think Robert's absolutely right. We can absolutely create massive shifts in healing on the planet if we're all deeply aligned to do it. I mean, that's part of why I created Unify with my homies back in the day, is because we believe the collective intention can make a massive difference. That's going to have to be my last words for today because I'm going to have to jump off. But thank you guys so much.
Thanks, Adam.
Always an honor and pleasure.
Thank you. Can I just add to that, that I would say that that's one reason why, if you are determined to create something in your own mind and you have a negative environment around you, it's best not to share it with anybody at all, because they add their influence to it and they even can, you know, by their own magnetism of their negativity affect you. If your result is that you really are focusing on something and you're the only one focusing on it and no one else is aware, it's a cautionary tale that is used in that old idea of, you know, of what we used to just call, oh, think positively. But I've too have proven it in my own life. If I keep it secret and I am absolutely focused on it, I can utterly make it happen. The moment you start sharing it, you invite in other minds to tell you you can't do it. And most people will want to tell you you can't do it. Because why should you be able to do that and me not? And how can, you know, it's just human nature. Ooh, look at him, thinks he's going to get out of Manchester. And you know, I mean, it's just the way people think, you know, so just keep it to yourself until you're strong enough, until you've got an environment around you like we have here that is strong enough to share it with that group who are not going to demean those ideas. And that's great. Until you're in that, I've just put that out to people in general because it's the way it operates. You know, you must protect those divine ideas and keep them and nurture them and water them, and they will grow. But if everybody else is taking the water out of it, they're not going to grow.
That made me think about the COVID situation. One thing is to say that won't affect me. I'm not saying it's not real, because then you have to accept that for other ones it's real. What I'm trying to say is that it is not as linear as that. I can only have an impact on my own life. I have to be like responsible for myself. So I can say, this is not part of my reality. I don't want it inside of me. I don't accept it. So that's when you have to, because if not, then whose intentions want to win, you know? So that's why it's not just about the intention. It's a localized intention that can only impact myself. When I decide that this is not my reality or that this is not going to happen to me, I'm not saying that the COVID is not existing, because I have to accept as well that for other ones, they wanted to exist, they needed to exist, they want whatever experience they're having through it. So this is why it is so difficult to have this point in which you have your intention like synchronized with yourself and cleared also, because there's many things, and we had that discussion in the French session last week about an intention, because many people ask why if I have a very, very strong intention, it doesn't happen. Well, it also happens that if your intention is not, let's say, not crystal clear, if it's not crystal clear, then it won't crystallize, you know? And so this is a very interesting topic, and it's not, I'm just saying that it's not linear like that. It's a lot of, because of course you have, you're allowed to have your own experience, and that is completely, and that's what it is all about. I mean, I want to have my own experience, and it is my reality. So yeah, it is. So there's some certain conditions to that. We are subject to conditionings. This is not determining ourselves. This is just conditions that we have to work through. So if we really understand these conditions and we really know how to play with them, of course we can create whatever reality we want. But this is something to explore. So I have to leave. Sorry, I'm very sorry. I have to leave as well. It's 1 hour later. So yeah.
Thank you, Ines, for being here.
Thanks,
Well,
Ines.
thank you very much. Bye, everyone.
Bye, Inez.
Bye. Bye, Robert.
Bye, Ines. Thank you.
Thank you.
Oriana, I trust your question was answered somewhere in the midst of all of that. That was amazing.
Totally clear now. I found it so confusing.
Really?
Yeah.
Yeah. Great. Well, thank you for being here again. Appreciate it. All right. See, Jamie, have you seen anything that's calling you to speak to here?
Well, putting me on the spot with 20 something questions. I actually would say we have Alan and Robert here not very frequently, and I will look for a better question, but I mean, Alan and Robert aren't usually here. I'm on every call forever. So let's have Alan and Robert chime in, because these guys have like lifetimes worth of stuff to share with you guys.
True.
Maybe I could find a question for them.
Yeah.
Let me see.
Well, there are no direct questions. At least I haven't seen any concerning the work aspect of what I bring to this group and the courses that are going to be launched, except to just say, to follow up on what was just said there, and I would invite Robert to give us his own experience of it too, because when we first met, I think we recognized in each other kindred souls of, it's hard to say this without sounding sort of full of yourself. That's not the intention at all, because literally I have been a creator in that sense all my life. The point is we all are, that's the whole point. We're supposed to be learning to get back to the truth, which is this indefinable thing of, not to get all religious, but there's a statement in the Bible about if ye have faith as a mustard seed, you can say to that mountain, move, and it'll move. And this sounds utterly, utterly ludicrous, right? We just go, what does that mean? That must be just a parable. There must be a metaphor. Surely you can't move a mountain with your faith, right? And then there's the other aspect of that people explain that away by saying, well, only when you become the divine will you be able to use that power, and then you know the mountain's in the perfect place anyway, so you won't want to move it. Right? You could, but you don't. There's all that. And I would just say, because I give a whole long presentation on this called The Missing I, and gave it at 1440, that big resonance meet that we had, what was it, 10, 13,000 years ago now, before this, this invisible thing that doesn't exist came. It's this, you focus and you focus and you focus, and if you can be more and more and more positive. I just use this analogy. If you think, you know, the number of thoughts we have is inconceivable, but let's say you have 50 positive thoughts in a day about what is your goal. And you sit down consciously in meditation and say, I see it, I see it, I'm there, not just I want it to happen, I'm feeling it, right? The way we're supposed to be, we're told we're supposed to be able to manifest. Think it, believe it, feel it, it's already there. And you come out of that state and you have 50 negative thoughts, because the mind immediately comes and says, who do you think you are? Right. Well, you can manifest that. You can make that happen. Oh, come on. And the mind does that because we've all had that input from our parents and from our friends, school and friends in business, etc., etc. People will tell you, ooh, you can't do that. And so you start thinking those thoughts. So you've got to be vigilant, and you decide on a regimen. I'm going to be vigilant, and I am going to try to shift this 50-50 where I will get nowhere at all. Because if I believe I'm thinking something positive and I'm actually reining it in, and the universe is, I'm pulling it towards me. If that's a law, I'm attracting it, but at the same time, I'm repelling it. The moment I let my mind say, yeah, but maybe, every thought we have is a divine prayer that is magnetizing that thought to you. If you think you can do it, you can do it. If you think you can't do it, you can't do it. And that is utterly true. But behind the scenes, in the mind, there's these gazillion thoughts that are going on that we're not even aware of. So at the end of the day, if you've had 50 positive, 50 negative, you know where you're going to be. So you've got to get the balance up. You've got to be thinking 75% positively and only 25% of the time saying, yeah, but, and then every time you get a yeah, but you go, no, it's a yes. And you counteract it. You're vigilant. And I know that I proved this to myself when I was a young kid, and I was just simply doing that and trying to manifest a cruise ship. I wanted to go get out of Manchester and manifest a cruise ship. And I just had a picture of a cruise ship on my wall and didn't know how to meditate. I didn't know anything about it. I just knew that I have to see it. I see the palm trees. I see the lush blue waters. I'm in rainy, foggy, horrible, cold, damp Manchester, you know. I've never seen a cruise ship. I've never seen water that looks like that, but I got a picture of it and I can imagine it and I can feel it and I can see myself playing a grand piano on this ship and getting all the attention that I wanted, right? Look at me, how great I am, woo! Right?
Alan, you manifested a Shakespeare question.
I did. What's the question?
Tanya is asking, in a previous Q&A, you said something about a connection between Shakespeare and a current member of the presidents of the United States. Can you share more about this connection?
Yes, a current member.
Well, it says a current member of the presidents in the USA. So a connection between
I mean,
Shakespeare
a former president, yes.
Yeah, a former president.
Okay, all right, well, I'll tie it to what I'm saying here. Because it's that idea that you magnetize things to you. Oh my goodness, I don't know if it's directly connected, but I mentioned that and didn't tell the story. Is that what she's saying? Is it Tanya? Tanya. Okay, well, Tanya, I'm scrolling and I can't see the actual spelling of your name. Is it Tanya, T-O-N?
I got it from
Anyway,
I got it from
okay.
David on WhatsApp.
Okay. Anyway, she wants an answer to that question about connected to Shakespeare and a president. Yeah. Okay. I'll tell you. I was
Tanya, hello.
I was 15 years old.
Say hi, Alan.
Oh, hi, Tanya. Hello, love. Where are you?
You have to unmute
You're
yourself.
muted. Where are you? You can mute. You can unmute now.
Okay. Yes, here I am.
Hi,
Hi.
love. Where
Hello,
are you?
Alan. Hello, everybody.
Hi.
Where are you?
I'm in Belgium. Belgium.
Oh, it must be Tuesday.
It must be.
What
Yeah,
does
Tuesday
that
night.
word mean?
Doesn't anybody know that movie? If it's Tuesday, it must be Belgium. It's an old movie. I'm 173 years old.
Mardi,
Oh,
Now that is an
that's-
obscure reference right there.
That's a movie, I tell you. If it's Tuesday, this must be Belgium. It's about being on tour and like, oh shit, but it's Tuesday, we must be in Belgium.
I have to watch the
Look it
movie.
up. It's I don't know if it's a great movie, but it is a movie. All right. So here, thank you for thinking of that, Tanya. Here's the deal.
Yes.
I'm 15
It
years
was
old.
it was about the numbers you were mentioning. You were not mentioning something about numbers, and that related to the numbers of presidents, I thought. That's
Oh, now you've sent me off on a whole other tangent. And no, I don't know anything about numbers. Gosh,
Yeah.
I don't know anything with numbers.
Yeah, you were mentioning the numbers. You were mentioning about the numbers 46, I think, 47. Or was it
624.
45?
Oh, I'm with you now. Oh my goodness.
Yeah,
Yes,
it was with an
yes.
introduction. It was just with the introduction you were mentioning.
Okay, I've got you now. Yeah. Oh, well, it was the last election that we just had, and we got rid of
Yeah.
president number 45, and we ushered in president number 46, right? And at that exact same time, I got the intuition to look at Psalm 46.
Yeah.
Because we were actually in the King James Bible, and Psalm 46 is this sonnet. I keep on thinking of it as a sonnet because most of my work is with sonnets. This is Psalm 46, and I look at it, and it's the thing that has this. There's a big question mark around it. Actually, can I share my screen and I could show you? It would be much easier that way. Can I just share a screen?
Yep.
All right. Okay. Thanks for bringing that up, Tanya. I completely forgotten that. Yes. All
Prepare
right.
yourselves.
Are you seeing my screen?
Yes, I see it.
Yeah.
Yes.
Might just zoom in.
No.
a
Are you
little
still
bit.
seeing it? Are you still seeing it?
No,
Yeah,
Or
not
is it
yeah.
disappearing?
no.
You know,
No.
like
Okay.
It's a black.
No, because it's all right. I just have to change my displays because I'm on 2 monitors, and so I've got to simply mirror my displays so that you can then see it. Got it. Okay. So all right. So now you see it. Psalm 46. This is direct from the King James Bible. And the reason that this is of interest is that Psalm 46 is the one psalm where 46th word from the beginning is shake, and the 46th word from the end is spear. And people have thought for years, is this anything to do with Shakespeare? I mean, what is Psalm 46 and shake and spear? What, is that all about? There's these, I'm going to switch to a different version of it because I've got a better version than that. Anyway, so here it is. I'm so glad you brought that up, Tanya, and I will.
Yes, me too.
It's possible. So it's this. There you go. The thing is, 46 word from the beginning and 46 word from the end are spear. The fact is, as I went into looking at this, and this is a rabbit hole that goes very, very deep, so I'm not going to go down into this whole rabbit hole with you right now. But yes, it is a clue, and it is telling us that Shakespeare himself, the true Shakespeare, which is now, I am utterly convinced, a group of people. Edward de Vere is, in my mind, still the main person who was Shakespeare, but Bacon is absolutely a part of it as well, because his name is all over the place and in various codes. So there's a group of avatar beings, I call them. They are ascended masters who were part of the what was called the Rosicrucians group at the time, that sort of morphed later on into what we call Freemasons, and before that they were the Knights Templar. And So they are doing this. They are giving us information secreted in the coding of numbers and sonnets and psalms, etc. But the interesting thing is, yes, it's 46 words from the beginning and 46 words from the end. But when you look into where was this translated from, it's actually, it was Psalm 45 in the original Greek, and they changed it to 46 just to make it fit the mathematics of this. So if you're looking on the left there, that's the original Greek, and it was called a psalm concerning secret things. And when they translated it, they changed the number to 46. And so in 46, it's called a song upon Alamoth, which means a song about, frankly, a virgin, and which is entirely part of the whole Shakespeare subterfuge, is that the queen, the virgin queen, had children that she kept secret. So all of this is being driven towards us, but the connection was just that I suddenly realized, wait a minute, we've just said goodbye to this old President 45, and I'm not going to make a political statement about it, other than thank God. and then I would say we got 46, which isn't necessarily going to be any better. It's just the political aspect of it. It's all a light and shadow show, right? But we got rid of 45, and in came 46. And at the same time, I was discovering, wait a minute, Psalm 40. It used to be Psalm 45, and now it's Psalm 46. And the point is, there's a whole lot of math hidden in it. That the word that used to be in Psalm 45 was troubled, and then they changed it to shake. And the word from the end was weapon, and they changed it to spear. And they weren't 46 word from the beginning and 46 from the end. They were the 50th word from the beginning and the 43rd from the end, and all these other things that have been made to happen mathematically happen to be there for a purpose. And the main purpose is to show us mathematical code. So I'm not going to go any deeper into it. I just wanted to, yes, thanks for asking the question. The point was 45 and 46. I'd completely forgotten about that. But it literally happened on the day that Biden was, when it was certified that he had won the election. I got this connection. I'm looking at it, I'm going, oh, it used to be Psalm 45. Why was that? And then it just suddenly hit me. So it's one of those bizarre things that are so-called coincidences, but probably not, because everything that we can imagine is somehow intimately connected to remind us of something and something. I mean, Robert, you experience that all the time, right? We just go, oh my God. Often, I mean, Robert will, I'll turn it over to Robert to talk about this, but we're always working on the same stuff. The reason he said earlier in the call, oh, Alan knows I was up last night, is because he knows Alan's always up. And he sees me post something at, I'll send him something at 4 in the morning or 5 in the morning, and he sends me something back. And sometimes we end up talking for a couple of hours. And it's crazy. Why? I don't know. I'll sleep when I'm dead, I guess. I mean, there's time to sleep. You get a rest in the astral for a short spell. I got too much to do right now, and Robert's the same. And the way it happens is, even though we think we're working on separate things, he will call me and we'll go, hey, but I will say, hey, I was just working on that, and he'll say, no way, we are working on the same thing from different, as though we're mining on two sides of a shaft, and he's over there and I'm over here, but we're both cutting away at the thing. We're going to meet in the middle somewhere. It's really, by now, it's no longer any surprise. It happens literally almost every single time. I'm working on
attest.
something. He's working on it, and they're coming in this way.
To be clear,
Go ahead, Robert.
I have the shaft.
You have this chat?
Shaft, the shaft. You said reminding the same shaft.
Oh, you have the shaft?
Yes.
Oh, you're not going to give me the shaft, are you? But what? Am I fired?
The only reason why I send Alan messages late at night is I know that usually I'm sending a message because I want to get some feedback and have a very intuitive group of people that can kind of like feel things, like remarkably quickly. Jamie is definitely one of those. And whenever I want to just test something and see, okay, am I off my rocker on this? And then I send it to Jamie or Alan or Adam or anyone else in the group or Nassim, and they're like, wow, then I know that I'm kind of in the right direction. So I'm looking for, some sort of response. And usually Alan's the only one who writes back at that hour of night because he's usually up. But I can attest to this. It's definitely true. I mean, Alan and I don't coordinate any of the work that we do, but we end up doing work like that's interconnected all the time. It's really remarkable. I remember one day I told him, I said, oh man, I'm just like, I keep drawing the letters S and G and the numbers 54 and 46. And he's like, let me just show you. And that's how specific it is. And then he's like,
and that was it. That was connected to the exact same psalm we just said, 46. And I happened to be then working on Psalm 54, and Psalm 46 starts with
G,
the G, and Psalm 54 starts with
S.
S.
And I didn't even know he was working in the Bible at all. I had no clue.
And they knit, but it's not just that, oh, those two numbers make 100. I mean, those two psalms actually have to go together. They fit together and they create a grid. And then when you realize what the grid is, it's a perfect grid. And right in the middle of it, right through the dead center, is everything that he and I have been working on for the last couple of years. I mean, literally everything, all right down to, and you go, what? And I've been working on those two psalms. And he had called again, 2 in the morning, 3 in the morning, whenever it was, and said, I'm working on S and G. Do you know anything about S and G? Why I keep getting S and G? Go, yeah, I might know.
Yeah. Mm-hmm. I heard you mention about that in another Q&A, just with introducing yourself. And when I heard it, something in my mind connected it to a short video that I heard about, I think, a little more than a year ago, of Baba Vanga. I don't know if you know her. She is a Baba Vanga. Yes, she's a Bulgarian mystic, clairvoyant, and she talked about the 45th president, or the 40, the presidents. And just hearing you mention that immediately connected me to that video that I heard more than a year ago. And I was like, what? So maybe there's
there
a
you
connection.
go. There's that entanglement again in a strangely different level. We tend to think, oh, entanglement must just be this electron is connected to this electron, though they're at opposite ends of the universe. It's deeper than that. It's as if that's not deep enough. It's down to the thoughts, our thought waves, our ideas, our creative dreams, our goals. They're interlocked. Because why? Because there's only one of us. There's only
one thing going on.
That's the truth. There's only one consciousness and one being.
Yeah, it's just that Baba Vanga, she was mentioning that President Obama was the last president of the USA. So I was like, well, is this connected? So we will see.
Wow.
I don't know. But I was just having a,
Yeah, no, we're glad you brought it up.
So that's what I wanted to ask you. We will see in the future. We always see in the future why we have that strong intuitive feeling about something, I think.
Yes, yes, you're right. That's another thing. Even if we don't understand right now what it is about, I have had this experience over and over and over again, where I think nothing is ever wasted. Nothing is ever wasted. It was always for a reason if you didn't get it at the time. My favorite anecdotal story to that illustrates it is 35 years ago, I was writing a musical, and I write the lyrics and the music, and it usually comes quite easily that I fit them together. But I wrote a piece of music that I could not get lyrics for at all, for whatever reason. I loved the music and the lyrics would not come. And then that was years ago, and I forgot all about it. And then currently, maybe just in the beginning of my working on the Shakespeare stuff, I started writing a Shakespeare musical, and the reverse happened, and I had some great lyrics and I couldn't get the music for it. And guess what? You know where it's going.
Nice.
I suddenly remember this music that I had written 20 years prior to that. And I went and I got the music out, and the lyrics that I had for this that I couldn't find music for, there was the music. It fit like that. And I went, I wrote the music for this 20 years ago.
Yeah.
That's great.
You know, and it just went stumph like that. Nothing is ever wasted.
Yeah,
And in
that's
fact, those things that get delayed are even more satisfying in some ways, because they're little reminders that make your heart burst. And you go, oh, yeah, thank you, the divine. Thank you, Lord. Thank you, my God. Thank you, Divine Mother, whoever you want to pray to, you know, thank you, because she's playing with us all the time and going, yeah, remember that? That's what that was for. It's really
beautiful. Yes, beautiful.
Beautiful.
Thank you.
Thanks,
Well, it's
Tanya.
lovely to have you here, Tanya.
Thank you.
Thank you so much.
So
for
awesome to
joining
be
us.
here. It's my first time live, so.
Oh,
You
really?
did great.
Fantastic.
You did great. We will invite you back.
Thank you. Thank you.
Yes, you passed the audition.
Thank you.
Say hello to Belgium.
Yes, I will.
Yes.
Bye-bye, everyone.
The whole country.
Bye.
Hey, Marshall, we actually have a good question for Robert from Anna Reed.
Yeah.
What's
Robert, Anna Reed says, what are you drawing?
Oh, who knows? Who knows?
It's a good
He's always
excuse to
drawing.
get Robert to hold up his notebook and show you some.
That's a loaded question right there.
Robert is constantly drawing. Here we go.
Yeah, here we go.
Let's see.
Oh, that
Yeah,
stuff
there you go.
again. Yeah.
Oh, yeah.
I've seen it.
Yeah, that stuff again.
Little shadowing.
What am I drawing? So actually, it's related to Randy's question, which is, has anyone evaluated the scalar measurement techniques of Elena Bensonoff? I haven't reviewed her scalar measurement techniques, but I've been getting a lot on scalar measurement techniques, which involve Euler and compass measurements. So the compass measurement appears to be, or maybe I can show you this real quick.
Euler, for those who don't know, is a guy that has a constant named after him. So he's talking about a number with an Euler constant.
That's right. And actually it's funny because this sort of makes you start questioning, you know, do we live in a simulation of sorts? Because, you know, and I think the jury's still out on that one, but, you know, maybe for lots of people, but I'm starting to think more and more we are in some sort of holographic simulation, just like the Hindus have said. But basically, let me just pull this up for you here. Here we go. Can you see this?
Yeah.
So this is
Yes,
what I'm drawing. This is what I was drawing. And what's really interesting about this is that you start asking the question, is like, wait a minute, when did the compass system come about? And actually you'll find in Wikipedia, it says that the Chinese were the first to use it, you know, minutes and seconds. But it goes way beyond that. It goes back to sexagesimal math, which is what our time system is based on, which is exactly what, if you think about it, you know, what we have from time came from the Sumerians. So the first ancient, you know, historical civilization that, you know, went from, you know, being kind of the hunter-gatherer stage into full cities and measurements for time and advanced mathematics and right angle triangles, and all of this came about in the same time frame. And in fact, all of the measurement systems we have today seem to have their roots even in that time frame. So here is the first civilization known to today's mankind. You know, we're talking about 6,000 plus years old. And some of the most advanced concepts that we think are completely arbitrary, the notion that we have 24 hours in a day, the notion that we have 86,400 seconds in a day, came from the Sumerians and sexagesimal counting systems. And so I have been finding some correspondences and correlations between these different measurement systems as I've been doing work on right triangles and factorization. And what I've found is that, in fact, you can take something that is supposedly entirely disparate, which is this notion of electromagnetism being disconnected to gravity, which I think all of us know that just doesn't feel right. Something about that just doesn't feel right. And it's the foundation of the schism that we have between sort of the quantum realm, and we can't really come to some reconciliation around how gravity actually works. And is gravity, as Walter Russell puts it, emergent from electricity, the one force in the universe, or is it, really something altogether different, like was, posited in several different papers in string theory, as well as, even with roots back into Kaluza-Klein, which had some connections also back to electromagnetism and gravity being kind of two opposite expressions of the same thing. And so in order to reconcile that, you have to reconcile measurement systems. Well, Alan's work has been probably the best on the planet in finding that all of the measurement systems that we utilize today were embedded into the construction of the Great Pyramid. How's that possible, right? I mean, even the latitude of the Great Pyramid into the King's Chamber, into the sarcophagus, is, the same number in degrees as the speed of light down to 1 meter per second. So it's 2.99792,458 times 10 to the 8th power. And that is the speed of light. And that is also 29.9792458 degrees north is the latitudinal reference for the location of the Great Pyramid. But not only that, even the other reference to the Great Pyramid, which is 31.1342 degrees east, that is the longitudinal reference to the Great Pyramid. And when we convert that and divide it into 360 degrees, you end up with 0.0864. So 31.1342 divided by 360 degrees is the same 0.0864 that is related to the number of seconds in a day, 86,400. So you have some theories that would say that, light and gravity are opposite conditions of electricity. So if they're opposite conditions, that would then say that time would be an expression of gravity. So here we have two latitude and longitudinal references on the Great Pyramid, that the pyramid was built thousands of years ago. If you believe dynastic history, then it was built, by Khufu in something like 4,500 years ago. But never mind the fact that it was the tallest building on the planet for over 4,000 years, and no one really thinks about that much, and it's still standing. Nowadays we have new buildings going up all the time that are taller than the last one. So when you look at it in that context, that means that unless this is just incredible coincidence, the pyramid is incredibly located on a light speed reference and a time reference. Seems like an incredible coincidence to me. I don't know. So what I've been trying to figure out, and I noted this, is that if you notice that the gravitational constant is 6.67408, right? And of course, there's all the units and everything that go along with that. But if you take the square root of that, you end up with 2.583. So 2.583 is unique because if I took that same number and convert it into minutes, right, of a compass, it would turn out to be 258 degrees and 58 minutes. Now that's interesting because that happens to be exactly Euler, the Euler constant. And the name Euler, by the way, is from a Swiss mathematician named Leonhard Euler. And his Germanic name, Euler, actually means owl. Now, we all know owls have this unique characteristic that their head can turn almost all the way around, right? It like spins. And anyone know how far an owl's head will spin in degrees? 271 degrees.
Oh, that's nice.
So wait a minute. The guy's name, Euler, is the
That's
same.
your average owl, right? That's just the average owl.
That's the average owl. That's right, the average owl. Thank
Okay.
you. Thank
It's
you.
not the extreme ends of the owl, just the
Yeah, but
average owl.
imagine it's a limiter, right? Euler is a limiter that puts a limit on everything. It does it to compound interest growth. It does it to, I believe, light speed. So if there's a speed limit for the universal speed limit, it would be the Euler constant. And the Euler number is 2.718, 271 degrees, really, of an owl's head. And the name is the owl constant. Okay, that's my one case for maybe it's a simulation, right? Maybe it's a simulation. It seems a little too funky, right? So, but when you take this and you figure out that this 2.583 converts to 258.58 degrees, and that happens to be 0.718, or Euler minus 2 times 360 degrees. And Euler's a limit, and gravity, of course, would be a limit. So Euler minus 2 times a circle, 360, gives me the square root of gravity. Don't you find that kind of odd, Marshall? Just seems, and it's perfect. It's not sort of, it's not kind of, it's not close, it's perfect. So then I go, well, wait a minute, what else can we find with this? Because the electron charge is 1.602, one something, I don't remember the rest of the number. And if we square that number, it comes out to 257. So really close. But when we convert the 257 also back into compass measures, it's 257.75. It comes back out to that same number, 2583. So it appears that there is some conversion that needs to happen when you're making conversion into scalar waves. Scalar being time and gravity, compression, longitudinal waves. Whereas transverse waves are light. So now we could put this in the context of Einstein's field equations, which would be based on right triangles. Okay, so you have side A, which would be distance traversed, side B would be time, and side C would be space-time as a hypotenuse. So what I've been working on is to say, okay, as a new concept, new theory, maybe side A, because it's transverse, is really related to the linearity of a square, and therefore it has a cube projection, but you can't see the other sides of that cube yet. It's like you're looking exactly on a cube, and we're just seeing a square. Just like I was showing you the cylinder, you can only see the circle. Side B is a hexagon, and it's based on base 12. You got base 10, and then base 12. And then it has a cube projection as well. But now you can see the full cube because the way that we're angled in perspective to it. And then we have an octagon for space-time, which is actually the form shadow of a tesseract's projection. And tesseract is commonly believed to be the way that time works in cubes, right? Because it's the most efficient way for space to stack. And of course, we have cubes all within the cube octahedron. We have cubes.
And octahedrons.
Yeah, exactly. Octahedron.
Makes hexagons, which makes hexagons.
That's
because
right.
The octahedron has the 4 hexagonal planes, so there it all is.
So what I'm looking at here is that time needs to be converted into base 12, scalar waves, the dodecimal system, imperial measurements. Side A is in transverse waves and metric, and side C is in sexagesimal why sexagesimal? Because that's where those two systems meet. 5 times 12 equals 60, and 6 times 10 equals 60. And 60 is a special number for the Sumerians to have chosen because it has the highest degree of compositivity, which means it has the most number of divisible factors for that size number. So it's very unique. And the other numbers that have those characteristics are all 2 to a power multiplied by 3 to the third power. So there's something with 2 to a power multiplied by 3 to a third power. So as an example, 2 to the third power multiplied by 3 to the second power, right? Or 3 to the third power, right? 2 to the third power multiplied by 3 to the second power, it turns out to be 72. And there's this weird sort of mirror reciprocity between those two, 2 to the third and 3 to the second. And I discovered in music, this tuning standard, which when I replaced the major third with from 5/4 relationship to a 1.26 relationship, which happens to be the cube root of 2, right? Another way of looking at 3/2, and the perfect fifth is 3/2. When you have the perfect fifth of 3/2 and the cube root of 2 for the major third, then you can have a perfect scale that sounds great. And you can use just tuning values, and only those two values together will populate the entire scale of music. So that's what I was working on. And due to Alan's great work, I think that I'm now taking this and saying, and putting concrete examples to it, because we also know that we can factorize numbers using right triangles. And so as you can see here, this side right here, side B, is 2 prime factors, x times y square rooted. Now this is a relationship we just discovered, and I'll make the announcement here. Jamie knows and Alan knows, but the paper that I presented in Peru, for those of you that were there, I presented some of the work of a paper that we then later published at Cornell, has just gone through a peer review process, and it was approved by the peer reviewers at Princeton.
That is awesome.
And it's going to publication, and it's on Infinite. The title of the paper is Infinite and Accurate Prime Prediction. Now that's interesting because think about this. How many times do we all see in the newspaper, oh, they discovered another Mersenne prime. They discovered another larger prime number, because it's not easy to do primality testing. Well, now people aren't going to do that anymore, because once it's gone through peer review, it becomes part of curriculum. And now it means that we don't need to do that anymore. We don't have to dedicate computer resources to that anymore, because we can simply do it by prediction. Right, through mod 24 analysis. So, and that included the discovery of a new kind of number called quasi-prime numbers. And so Talal and I published that paper, and we're very excited. And our book is coming out in another month or so. So very excited about that too. And Marshall's book, I would have put a plug in for his book. His book is outstanding. If you haven't gotten it, please go get it and do yourself a favor. So I think that there's something here with space-time and the combination of scalar and transverse combined, and the unit of measure of that is the most ancient, which is the cubit. So that's kind of mind-blowing. So you got on side B, foot, yard, right? On side C, you've got cubit, and side A, you've got metric. Now this is getting really interesting, because then you could take X and Y 2 prime conditions, square root. Then always C value will be X plus Y divided by 2. The symmetry that nature uses is, just as I said, 3/2 and cube root of 2 for the perfect fifth and the major third. Yeah. It's done it again here, divided by 2, square rooted. So this is the product, square rooted. This is the sum divided by 2. And side A becomes Y minus X divided by 2. So then to find the 2 prime numbers that created that experience in space-time is C minus A multiplied by C plus A. And it works every time. That is prime factor. So
simple.
It is so simple.
Phenomenally simple. Wow.
It is so simple. Now, the next step I'm drawing here right now is the next step, which is to actually take this and put it into numbers where we can actually understand it and then show a model and prove a model. The nice thing about math is it's the cheapest form of research because the proof is self-evident. We don't have to do experimentation. You know, I sent this funny video to Nassim today, which was hilarious, right? And I said, this is when math and physics perfectly match.
A little choppy, but there's a guy sliding down a slide, flying through the air into a swimming pool.
Can you imagine how hard it would have been for them to come up with the math and the physics? I mean, how many variables do they have to come up with? And it's like, well, let's test this out. No, it's okay. I don't want to be the one who's going to be the guinea pig on this, right?
I'm sure there must have been a test dummy in there somewhere. Oh my
Totally
God,
right.
that's-
I mean, it's pretty funny. So what
It is.
the next step of this then is, if this proves out, and I have a feeling it's going to, because I always get these feelings when I know I'm going to basically solve something. When this proves out, what we can do is we can replace these values with E equals MC squared.
Mhm.
In a right triangle, to
Lay it all
find the
together.
exact relationship
Mhm.
of mass.
Oh, nice.
And because my theory is
Oh,
that
yeah.
time is just the opposite condition of energy.
Mhm.
So when we think about it from that context, right, you could say it's like latency. It's a measurement of potentiality. And the fact that we've got C squared, so, you know, you could take side A of that equation that I just showed you of a right triangle. Side A is the area value is C squared. And that's why it has to be speed of light squared, because it's part of a Pythagorean triangle. That relationship. Mass is a different way of looking at vacuum volume. Because remember, 99.999999999% of, as Nassim always says, you know, 99999 in his voice, right? Then it's actually just vacuum that connects everything. And then we can take an equation, which is, you know, the value of psi, PSI, right? Not Planck spherical units, but psi, the Greek letter, is 5.16 times 10 to the negative 93rd power is the vacuum density, the Planck density. So I believe that that's where this is going to go. And that we're going to find that the ancients left it all for us in a giant cipher in the Great Pyramid for us to measure and understand who we are and what we actually are. And it's uncovering like a big encryption, you could say. And that once we understand the relationship between that time and space-time is simply a function of a right triangle calculation, which is exactly what was posited, by the way, by Einstein and general relativity. I think we're going to understand the linkage then to energy, which then means that if you can reverse energy, some would say that you should, in theory, be able to reverse time. So that's what I was, so to answer the question, that's what I was drawing.
Anna, you got your answer. Why don't you unmute and say hi? Yeah.
Thank you, Robert.
Thank you.
Thank you all. That was amazing. I'm sure I'm just trying to let it in and let it flow over me. You know, it's all, everything's all happening there at once. So you're not gonna pretend like
you have it beautifully illustrated behind you, very accurately illustrated on the wall behind you.
Right? That's how I feel.
Yeah, that looks about right. Yeah.
You got it.
But yeah, it's so amazing. And on the end of like the being assimilation too, and the pyramid being like perfect phi ratio of, right, the longest stretch of land or on Earth right now, right? So it is pretty unbelievable. So This is amazing. I'm
Mhm.
glad to be part of it with you all, and keep up your good work, because you guys are obviously on the right track.
Thanks.
Thank
Thank
you.
you, Anna.
We like to think so.
Thanks for being
That's
here.
what Jamie.
We've convinced
funny,
ourselves.
is, Jamie said that when I was driving on the way to the office, and Jamie's like, "Whoa, whoa, whoa! Tell him what you said." I can't remember exactly what you said. You said, "Have you told Alan this yet?" Oh my gosh, that's where this is going.
Yep. Because you guys, I mean, you get a taste of what these guys are up to. I'm in contact with them on a daily basis for months and months. And so I see the intricacies of what they're doing and how it relates to what Nassim has been doing for 30 years. And so it's an exciting time because Nassim is furiously working on a new paper with Dr. Olivier Alarol, and they're getting really close. And just like Robert, they keep coming up with new insights and new profound connections that make them have to go back and like re-assimilate. And so it's extending the length of when they think it's going to be done, because it keeps unfolding and unfolding, but it's getting closer and closer. You know, we're like, you can tell that unification is like super close around the corner. And as we've heard, if you can actually unify physics, then you can be like, oh, that's how the universe works. Okay, let's make all our technology work in harmony with the universe instead of blowing up the universe, right? Combustion.
Nice.
Once we have
Good
that,
concept.
as you know, it's infinite abundance. We have like as much energy as we need. It's not how much money can I make? It's like, how beautiful can we make everything? How fun can we make Earth? You know, how healthy can everything be? That's where we're going to shift, instead of like, can we save ourselves? You know, it's like, yeah, we're saved, and now let's make it fun. I think that's where we're going.
Yeah.
That's where I'd
Yeah.
like to see it going. And that's part of what Resonance Science Foundation is doing. And so you guys are really super, you know, helpful in just being on this call and listening to this. Even if you don't understand, it's going to absorb, and it helps the field. It helps the whole thing just by, you know, feeding the information back to the universe. So all that to say, thank you guys for being here. Robert and Alan and I, all three of us, are 3 minutes late for a meeting right now already.
I told him to push it. We've got 5 more
Okay.
minutes. Fine, I pushed it. So, and I wanted to show something as well. You know, I was
All right.
talking about this. I was talking about this thing about, you know, taking electromagnetism, taking Euler -2, multiplying it by a circle, and then you land exactly at the square root of gravity. And then I said that through a compass conversion, that's really just the electron charge squared is the square root of gravity. And then when you do another compass conversion on it, it splits into 2 parts. It actually turns into gravity on the one using scalar conversion, then using decimal conversion, it turns to the Planck constant, 6.626 versus 6.67408 for gravity. And that's all from the same starting point. It's just using different measuring systems of the same numbers, just converting from scalar using sexagesimal math back into decimal and dodecimal math. That's it. So now electromagnetism is the square root of gravity. That's a mind blower, right? All by itself. But
Mind blower, and it almost seems obvious when you kind of get to that point.
Well, and
It's a
so
mind
what
blower.
happens is, for me, when I start getting, and these guys know, when I start getting new geometry discoveries, right? Which discovering geometry for me has become like a Sudoku game. And you know, Alan's got his grids and I have my geometry, and it's a different way of coming at the same issue. It's really interesting. So what I do is I'll draw a Metatron's cube, or in this case, I used 8-point perspective to discover a geometry. And then the ultimate test is, does it close? Can you actually build it? Can you make it? And this was an entirely new geometry that I've discovered now about 20 new geometric structures that have not been seen before. But this one is an entirely new one, and it had such a cool shape that was such phi relationships because it's all pentagonal. And it looks like a crown. So you could see this upside down inverted pentagons. These are regular pentagons around the center. And you could put it on your head, it looks like a crown. It's pretty cool. And then there are irregular pentagons, 4 of them on the top and 4 on the bottom, and they're all the same. And the only one side link that's different is going to the points at the top and the bottom. And that side length is Euler -1. All the other sides are 1. So Euler -1 being the Royal Egyptian cubit, which is the combination of sexagesimal math. And so this is built into this geometry, which then led to, of course, a dual, because then you could just take the center point of each of these and construct another geometric structure, which is what we did.
Looking good then.
Yeah,
Cool.
yeah, right. I know. All these people that like, so another geometric structure that came out of this is this. So this structure came out of that. This is the dual of that new geometry. And so this actually got my name, the granthahedron dual. The other one is the granthahedron, which is just pentagonal, 16 pentagonal sides. If you look up on the internet, 16 pentagonal sides, you will not find any geometric form with 16 pentagonal sides, regular or irregular. And this is the dual that closed as well. And it's kind of got an icosahedral form to it. It's like a twisted icosahedron. And then most recently, and that was the drawing, I find this mess of lines, and from the mess of lines, I kind of figure out what will close. And then it's so bizarre, but when you draw it as well, the backside even shows up. So as you can see here, there's a backside to the geometric structure, and it matches perfectly. It just comes out as inherent lines within the geometry of either 8-point perspective or 6-point perspective. And what I keep getting is that we're moving to 8-point perspective. So this is the first pentagonal hexachidecahedron is what it would be called technically. And then, there was another geometry that came out of that as well, which is this one. Another entirely new geometry that was found. So I have to kind of record all these and then put them in and submit them. It's like a lot of work. But, what's interesting about the new geometry that I found as well, the one that I just showed you that was pointed on both top and bottom and all pentagons, 16 pentagonal sides. If you take 16 and multiply by 540 degrees of each of those pentagons, even irregular pentagons are 540 degrees, then you'll find that it comes out to 8,640. Which is light speed in miles less the 1 in front. 186,400 is one of the measurements of light speed. So it's interesting, right? That this is showing up like this all over the place. And every time there's new geometry, there's new knowledge. There must be, every time we have new knowledge, there must be new math and new geometry that comes along with that new information.
Right.
Geometry is nothing more than the coherence of consciousness. So
yes,
I'll end on that.
Bucky's the subtitle to Bucky's Synergetics: Explorations in the Geometry of Thinking.
Bucky said that geometry is the coherence of consciousness.
No, the actual subtitle of his book Synergetics is Explorations in the Geometry of Thinking.
Oh, interesting. Okay.
Yeah,
that's cool.
So there you have it. Well, fantastic. What a session. So glad you guys are here today, sharing remarkable findings and insights, as always. I do wish you a little rest here and there, but in the meantime, keep at it. It's pretty damn cool.
It's not going to happen.
It's not going to happen. Like you said, everyone died. Fantastic. We'll leave it at that for today. I know I need to jump off and get on to what's next for me here. And you guys do too. So thank you, Robert, Alan, Jamie, all the rest.
Thanks, everybody.
And everybody here today joining us once again for a great session. Amazing. We'll see you next month.
Thank you.
Everybody take care.
Bye, everyone.